Hi, my name is Parivel and this is Ashwin. We'll just get started with a quick background about us. So, Ashwin and I, we've known each other since school. We went to different IITs and then we graduated in 2020. Ashwin worked in credit insurance for about 2 years, and then I co founded a legal tech startup in the US. During COVID, we both saw up close how fragile the entire healthcare system was. Patients and we spoke to a lot of patients and doctors, and we kept hearing the same thing. After the patient leaves the hospital, the post care from the doctor basically ends. There is no way for the doctor to stay connected with the patient post the consultation. There's no way to track outcomes, and there's also like no way to there's a big gap between the treatment and the recovery. So that's when we decided to start this AI powered startup. So when the AI wave began, we understood that these are the systemic gaps that AI can actually bridge. So that's when we decided to go forward and build the startup. And we are backed by Karthi, who's a ex McKinsey partner who's worked with a lot of insurance teams and government health programs. We also on our team we have a couple of like directors from different hospitals. We have insurance from CXOs, and we are also supported by a couple of IIT professors. So we're talking about two problems here. One problem, like we discussed, is the post-care cliff. So on one side you have doctors, and the other side you have patients. So after the consultation ends, like I said, the distance between the patient and the doctor is increased. So on one side, the doctor is busy with other patients; they're busy with admin work, and on the other side, you have patients who don't have an exact way or a channel to reach to reach the doctor, and that's when they turn to like WhatsApp forwards, non-medical influencers on social media, YouTube, and Google searches. So this is where like trusted guidance ends and like unverified medical advice starts popping out. So that's the first problem. The second problem. So second problem is there's a broken bridge between hospitals and insurers, and patients are stuck in between. So hospitals are burdened with a lot of like burdened with a lot of paperwork for pre-auth claim and also during discharge, right? So patients have to wait for hours before their discharge gets cleared, and claims are often um, like rejected because of incomplete documentation, or if there's a small mismatch between the medical notes and the actual claim submission. So this broken bridge adds to the stress as well as the cost of healthcare. And if we zoom out, we're talking about a bigger problem. So in Indian healthcare, especially, so we call it as a 3A crisis. There's accessibility, availability, and affordability. So accessibility, it's mostly limited to infrastructure and distance barriers, especially in rural areas. So we're not going to focus on that for today. We've decided to take up the next two problems, availability and affordability. So about less than 40% of the patients actually follow their prescribed treatment till the end. This is what we've observed, and fewer than 10% doctors actually have the time to proactively engage with the patient. Once they leave, to track what's happening and everything. And more than 50% of the patient's episodic lifetime value is actually captured by non-medical influencers and unverified medical advice rather than the doctor. And when it comes to affordability in India, like almost more than 45% of the total healthcare expenditure is out of pocket. And like I said, patients wait like on an average about 12 hours to get their discharge cleared. Those are the two problems that we're talking about. And how are we going to solve these two problems? We are trying to build two bridges. So one we call is the availability bridge, and the other one is the affordability bridge. Availability bridge, we call this as a solution called Nalam. So what this does is it tries to bridge the gap between patients and doctors. So it powers patient adherence through intelligent nudges. So the conversation between the doctor and the patient is transcribed. We try to generate structured medical records using which the follow-ups are done. And it also has like a couple of AI powered solutions for the doctor where they can query through the patient records. They can create digital twins of themselves to enable consistent care. And this is already being piloted in about 10 plus hospitals in Coimbatore. And the second one is the affordability bridge between hospitals and insurers. So that is where Iris comes in. And Iris was completely built just using Anthropic suite of solutions. And like I said, we're going to bridge the gap between hospitals and insurers. So we are looking at two agents here. So one we call as the pre-auth agent. The other one is the discharge reconciliation agent. So pre-auth agent, we aim to generate medical notes, for pre-auth claim approvals, and the discharge agent, it reconciles all the claims, the forms, to process like a hassle-free and error-free discharge processing. So, using these two bridges, we hope to close the gaps that make healthcare episodic and expensive. So, Ashwin will walk you through Iris in detail. He'll tell you how we built it, how it works, and how we leveraged Anthropic suite to build it. So, yeah, over to
Thanks, Pari. Again, a good afternoon to all of you. So let me walk you through what is Iris and how it works. So, so just to give you a brief context. So currently, let's take a cashless claim. So there are two stages to this. There is an pre-authorization stage wherein the patient informs the insurer, "Hey, I want to undergo this surgery," and the doctor gives a medical note detailing why the surgery is needed and all the cost breakdown and any other investigation that's been done. And then comes the discharge module, wherein you have the final bill, you have your discharge summary, and you're praying that, hey, your claim is going through so that you don't have to pay out of your pocket. Now, Iris again has two layers or two flows to be exact. There is a pre authorization flow, and then there is a discharge flow. So, let me actually walk you through the demo so that I can tell you what is actually going on behind the scenes. So, this is just a simple UI. So, let me choose the policy first. I've chosen the pre authorization module, then the policy date. And well, today or tomorrow seems like a good day to get admitted. And then let me just, all right. Okay, now it's processing the documentation. So what exactly is happening? Well, there are three things that's happening. One is the policy compliance checker. Now, every policy has its own terms and conditions. Your waiting period, whether it's covered or not, and any ceilings or eligibility limits. And this checks first with the taking the uploaded details. It first checks with the compliance checker to see, hey, if everything's all right. It's an obvious validation, but sometimes obvious mistakes are the most difficult ones to avoid, right? And then you have medical context reviewer. This takes to say if the surgery proposed is actually in line with the diagnosis or with the symptoms proposed or with the investigations results. It cannot be that a doctor is proposing brain biopsy for a headache, right? And then the third is an abnormality observer, which again, it's like two sides of the same coin. It checks if there are any, you know, difference or an abnormalities observed. So, for example, for a simple appendectomy, it's an one-day surgery. But if you're hospitalizing for 3 days without any justification, then it flags that. So this is how each of these, agentic workflows work, and then they finally give you the suggestions on where to improve so that it's not a hassle for you as well as it's not a hassle for insurer, right? You don't want to make life difficult for insurer. That's very bad, right? And that's how it gives you the result. So it's only 70. Let's see what the issue is. Ah, room rent is more. Again, the obvious mistake. And then it is suggests that there's some insufficient justifications, and then there are some insufficient evidence, and yada yada. So what I'll do is I'll save this for discharge validation, so that I can then directly fetch these values for while processing the discharge validation. Now, at the time of discharge, you have your final bill in your hand and the discharge summary in your hand. Again, it fetches the details and then it's processing. Let's go back to the slide. Now, after treatment, again, there are a couple of agentic workflows that are doing the work. One is the cost escalation analyzer. It checks whether the final bill is in sync with the pre-authorization estimates that have been given, and then it flags if there are any variants noticed. And then there is a treatment compliance reviewer, which again checks if the treatment done is actually in sync with the treatment proposed. It cannot be that treatment was proposed for left eye cataract and it was actually done on right eye, right? And then if there are any variants observed, then another justification finder or a justification validator is called, which basically takes all the data, your patient details, your medical note, your final bill, discharge summary, policy data, everything. It keeps everything in front of it and says, for this treatment, is this complication noticed? Is it correct? Or is it normally noticed, this complication? And if for this complication, if this type of justification or intervention is correct, so it thinks and it comes to a decision, and then it says, okay, is it all good, or it is, and it doesn't necessitate other further notes or further information, or does it need to go back to the doctor for complete rewriting and everything, and finally gives the suggestions. So it needs clarification. Why is it that I think 0 items? So let's see what the issue is. Okay, so the cost is justified. The hospital stay was extended for 1 day, but it was completely justified. So why is it justified? So a small deviation occurred, during the surgery or anything, and thus the justification, the hospital stay had to be extended. So this is a simple, you know, way on which how Iris works. To be honest, we had an idea of Iris. We were planning to build it, but then with all the advancement of AI and agentic flows, we thought, hey, we have an idea. There's this agent. What could go wrong? So this was completely built using Claude code. In fact, I would have to say I'm not a developer here. I'm a project manager. I play the role of project manager or architect here. So everything was done by Claude code. And then, as you can see, there were multiple agentic flows that require critical thinking, contextual thinking. So we were able to leverage Claude's, contextual thinking, and also the fact that humans talk through words, right? But agents talk through JSON. So the structured output, uh, feature, we were able to leverage that. And going on, going forward, this is just an agentic flow. We want to make it a fully, completely autonomous agent, where it can even search for different um, surgeries, and it can automatically decide if this is good or bad. And insurers and hospitals can add their own criterias and context before we even to make it even more robust and complete the flow fully. So this is something that we have. So thank you, everyone. Thank you for being such a pleasant crowd.